Okay, in this video we'll review some facts about lines. I had actually recorded a video before this, but when I played it I realized that the fan was really loud. But now I've turned the fan off, so hopefully it will be okay. But since I've already recorded the notes, I'll just go through them. So lines are a really important part of mathematics and will show up a lot in calculus. So first let's just review the coordinate system, the Cartesian coordinate system. So you have the plane and you take a point on the plane and you call it the origin. Right, this point here is called the origin, and you take two number lines and you make them perpendicular. And once you do that, you can label every point on the plane with two numbers, and those are the coordinates, the x and y coordinates. So the x comma y ordered pair is called the coordinates of the point. If someone asks what are the coordinates of this point, you could think of it as the x coordinate is 2 and the y coordinate is 4, but what they're really asking you is what is the ordered pair. So it's 2 comma 4 with the parentheses. And with this coordinate system, you can give a precise mathematical definition of a line. Remember that in math, we need to give precise definitions of what we're talking about, so that we can say something about them. And to get an idea of what the mathematical definition of a line should be, let's take a look at some examples. Let's say you take the equation y equals 2x and look at the graph. Remember that the graph of an equation is all the points that satisfy the equation. So all these green points, like 1 comma 2, here's 1 comma 2. 1 comma 2 satisfies the equation y equals 2x, because if you plug in y equals 2 and x equals 1, you do get that y equals 2 times x. And it's the same with other points like 2 comma 4, 0 comma 0, and these are real numbers, right? So they can be literally any real number x, and y will just be 2 times that number. And if you take all those points, they form what looks like a line. The graph matches our intuition of what a line should be. And in general, y equals mx, no matter what the constant m is, will look like a line when you graph it. And similarly, if you have y equals x plus 2, for instance, that also looks like a line when you graph it. And in general, the graph of y equals x plus b for any real number b also resembles a line. And in general, if you just have a constant m and a constant b and you graph y equals mx plus b, it looks like a line. It matches our intuitive idea of what a line is. And we actually use that to give a precise definition of a line. Well, actually, we define a non-vertical line to be a set of points satisfying an equation of the form y equals mx plus b for m and b real numbers. And the vertical line is the set of points satisfying an equation of the form x equals k for some real number k. And we define a line to be either a non-vertical line or a vertical line. So now we have a precise mathematical definition of a line. Alright, let's talk about the slope of a line. So the slope of a line is very important. Let's say that you have a line whose equation is y equals mx plus b, and you take 2 points x1, y1 and x2, y2. And let's say you calculate y2 minus y1 all over x2 minus x1. Well, y2 is equal to m times x2 plus b. That's because the point x2, y2 is on the graph of the line y equals mx plus b. And similarly, y1 is equal to m times x1 plus b. So therefore, when you plug in those into the numerator, y2 minus y1, you get this. And when you simplify, you do the algebra and you get that y2 minus y1 over x2 minus x1 is equal to m. Now notice that y2 minus y1 over x2 minus x1 is a measure of the steepness of the line. If the line is really steep, then what happens is that y2 minus y1 is really big relative to x2 minus x1. So for this reason, the constant m is called the slope of the line. So every line has a slope. Let's look at some examples. Let's say that you have a horizontal line, y equals k. So for instance, y equals 3. Well, that can be rewritten as y equals 0x plus 3, so the slope is 0, because it's the constant being multiplied by x. And the fact that the slope is 0 makes sense. The horizontal line isn't steep at all, so intuitively you would want the slope to be 0. And you can actually check that another way to see that the slope is in fact 0 is if you take this point x1 comma 3 and this point x2 comma 3 and calculate y2 minus y1, you get 0 because it's 3 minus 3. Let's look at another example. Y equals negative x plus 2. Well, that has slope negative 1 because this is the same as negative 1x plus 2. Alright, let's interpret b. So we have an interpretation of m. It measures the steepness of the line. And this is only when your line is not vertical, because if you have a vertical line, the slope is undefined. Now let's look at b. So notice that if you have an equation y equals mx plus b, right, when you plug in x equals 0, you get y equals b. So 0 comma b is the y-intercept of the line. And that gives you an interpretation of b. It's pretty simple. It's just when x is 0, what's y equal to? Okay, so we've learned the definition of a line. Now, there's multiple ways of writing an equation for a line. One of them is the point-slope form. So if I have y equals mx plus b, suppose that I have a point x1 comma y1 on the line. Okay? Well, we've learned that if you take any point on the line, say x comma y, we know that this ratio y minus y1 over x minus x1 has to equal m, the slope. And if you just multiply both sides by x minus x1, you get this. And that's called the point-slope form of the line. Conversely, if you have that line, if you start off with this equation, you can always get it back into slope-intercept form. That's really easy. You just distribute the m across. So when you distribute the m across, you get this, and then you add y1 to both sides, and you get, oops, whoa, I did not intend to do that. You add y1 to both sides, and you get this. And that has the form mx plus b, because our b is just going to be, right, our b is negative mx1 plus y1. Okay, so you can always go from point-slope form to slope-intercept, and if you're given a point, you can figure out, if you're given a point on the graph and you are given the slope, you can figure out the point-slope form. Alright, let's talk about intersection points of lines. Well, this is just something I'm not going to go too in detail on. So let's say you have this blue line and this green line, and you want to see where they intersect. Well, suppose that we call our intersection point x0, y0. So here's our intersection point. How do we find it? We know that it lies on the green line, and so therefore we have that y0 is m times x0 plus b. It also lies on the blue line, and so therefore y0 is n times x0 plus c. Therefore, okay, whatever x0, y0 is, both equations have to be true. And since m times x0 plus b is equal to y0, and nx0 plus c is equal to y0, therefore, m times x0 plus b has to equal n times x0 plus c. And if you do some algebra, you can solve for x0 here. And then once you solve for x0, you can just plug it into you would plug it into the equation, because it doesn't matter which equation you plug it into. Plug it into either one of the blue or green equations. This one I plugged into the green equation, and I solve for y0. And that's how you find the intersection point. Now, you don't have to memorize this, but the point is that you should be familiar with how to find the intersection points, and you should be able to do this with arbitrary symbols like this, not just with specific numbers. And by the way, here I'm assuming that the two lines actually intersect. If I have parallel lines with the same slope, so that would be if m is n, they don't intersect. Because, the first line will be y equals mx plus b1, and the second line will be y equals mx plus b2. If they intersected, then the y coordinate would satisfy mx plus b1 equals mx plus b2. And that would imply that b1 equals b2. Right, but that can't happen if you have two different lines. Okay. And there's also the standard form. The standard form of a line is ax plus by equals c. And what's nice about the standard form is that, so before, with non-vertical lines, you have y equals mx plus b, but then you have a different form for vertical lines, and that's x equals constant, x equals c. Right, so that's not ideal. I mean, for the standard form, you actually get all the lines at once. You don't have a separate thing for vertical lines. Because if you said b equal to 0 and a equal to 1, you get x equals c, which is an equation of a vertical line. If b is not 0, then you can solve for y and get something in the form y equals mx plus b. And if you have something in the form y equals mx plus b, it's really easy to get the standard form. You just subtract mx from both sides and you get this, which is in the standard form. Right? Your a would be negative m, your b would be 1, your c would be b. Oh, and then one thing I forgot to mention is perpendicular lines. So let's say that I have let's say I just have this line through the origin, y equals mx. Okay. And so this has slope m, right? Now let's say I want the equation of a line that's perpendicular to that line. What's the slope of the perpendicular line? Well, one way to see what would happen. So I have the origin, and I have this point. Let's say x is 1. Then, since it's on this line, y is equal to m, right? Now, if I imagine what I get when I rotate this by 90 degrees, so if I have a 90-degree angle and I rotate it by 90 degrees, the corresponding point here turns out to be negative m comma 1. And I know that this blue line goes through negative m comma 1 and 0 comma 0. So then the slope of this line is, so I look at the change in y, 1 minus 0 over negative m minus 0. That's negative 1 over m. So in this case, the equation of the line is y equals negative 1 over mx. Now notice that the two slopes, m and negative 1 over m, multiply to negative 1. And that shows that if you have a non-vertical line, then the perpendicular line to it has a slope that's the negative reciprocal. So slopes of perpendicular lines are negative reciprocals of each other. You take the reciprocal and then multiply by negative 1. Of course, this doesn't make sense if if your original line was horizontal. I mean, if it was y equals 0, then the the perpendicular line would just be the x-axis. No. It would be the y-axis, right? X equals 0. Okay, and then what happens if your original line is, not through the origin, mx plus, some non-zero b? Well, this line has the same slope as y equals mx, which is m. And so this has the same slope as y equals mx, right? And then the perpendicular, see this line that's perpendicular is still perpendicular to this line. It's perpendicular to the original line. And any line that's perpendicular to y equals mx plus b is going to have this slope. Okay, so it's not necessary. Here I was just looking at lines through the origin, but it's true for any lines. Okay, that's all I wanted to say about lines. Thanks.